Good morning, students. We are studying chapter the human angle of the world, and we have studied about the glass prism. Glass prism has two triangular faces, three rectangular faces, and through the glass prism we can disperse the light. And now we know what is the dispersal of light and what is the spectrum of the white light. In last lectures, we understand that the spectrum of the white light is the seventh color which is formed after passing through the light through the glass prism. When the light passes through the glass prism, it is split into the seven colors. And this seven color band is called the spectrum. And what is the dispersal of white light? Dispersal is when the light is split into seven color when it passes from the glass prism. It is called the dispersal of the white light. So we have learned how the dispersal of the light takes place here. What is the spectrum of the light? Now, in glass prism, we understand how the dispersal of the light takes place when it passes from the prism. Since the light is made up of seven colors, and then it passes from the prism, these seven colors has different speed in different medium other than air. In air and vacuum, different lights have same speed, but in other medium other than air or vacuum, the different color has different speed. So, due to which the light in the seven colors split into seven colors. Like this is a prism. I explained in the last lecture that this is the white light which is coming towards the prism. When it entered into the prism, the light which is the lowest speed, it is a violet color. We found it at the bottom of the spectrum, and the light which having the highest speed with all these seven, we found it at the top of the spectrum. With you. So now we know that how the dispersal of the light takes place through the prism, and why it takes place, what is the cause of dispersal of the white light, and again what happens if we place inverted prism in near it, like this is a prism and we are placing an inverted prism. Similar inverted prism means they should have equal angle of prism. Now, with the white light passes from the first prism, it disperses inward seven color. Again, when it passes from this prism, which is placed inverted near this prism, these faces should be parallel to each other. So, these seven lights again combine to form a white light. So this is called the recombination of the prism. So we have been studying probably in last lectures. I explained you all these function of prism, how the recombination of the white light takes place. Now I am going to explain you a rainbow. The rainbow formation, how the rainbow formation takes place. Before understanding the rainbow formation, we should know a single term, that is a total internal reflection. So what is the meaning of the total internal reflection? Actually what happened? This is suppose a denser medium, this is a rare medium. And we know that when the light passes from the density of the rare medium, it always bend away from the normal. So like this is the normal and the light is coming from denser to rare medium. It will bend away from the normal like this. Now at a particular angle, you can imagine that if you are going to increase this incident angle of incidence, what will happen? The angle of reflection also increases. So at a certain level, we are increasing the angle of incidence. The angle of refraction can be of 90. Yes, it's possible. So this angle become of 90. And what happens if we increase this angle? Actually, this angle at which the refracted ray passes at an angle of 90. It means at which the angle of refraction is of 90 is called the critical angle. This is called the critical angle. And if we increase the angle of incidence more than this critical angle, then what will happen? If we increase this angle, the light will refract on its own medium. It means when the light is passing from the density to the rare medium and the incidence angle is more than the critical angle. Now you know what is the critical angle? The critical angle is at which the refracted angle is of 90. So after if the angle of incidence is more than the critical angle, then the light is refracted on its own medium, and this is called the total internal reflection. This reflection the light is passing from denser to the medium, but it reflects back. And I explain you what is the condition for the total internal refraction of the light. The light should always passes from the denser to the medium. This is the first condition. And second one is the angle should be always greater than the critical angle. So this is the total internal refraction. So before understanding the rainbow formation, we should know what is total internal refraction. Now this is suppose this is the raindrop. You know, in rainbow formation, when the rainbow formation takes place, two conditions necessary. That there should be rainfall as well as the sunlight. So these two conditions are important for rainbow formation. So when the raindrops are in the atmosphere and the sunlight falls on it, then what happens? We know that air is a rare medium and water drop is a dense medium. Now when the light is coming from, suppose there is sun and the light is coming from the sun. Now it entered from air into the denser medium, that is a raindrop. Now what will happen? Since this is a rare medium, this is a denser medium, so we all know that it will bend towards the north. As well as the light, the different color of light having a different speed in different medium other than air or vacuum. So we can say the light is split into its seven colors. Okay, again I can explain you that this is air and this is water drop. Water drop is a denser medium, air is a rare medium. When the light is passing from the air into the denser medium, that is a raindrop. What will happen? First, it will bend towards the north, since this is the denser medium. Again, the second thing is the different color of light, that is the different color, it is seven color of light with you. These seven color has different speed in different medium, means like in water. So it is split into its seven color. So here the light is split into its seven color like this. This is with you. Okay? With you. Now what happened actually at a particular angle? It can be happen that the angle of incidence can be more than the critical angle like this. Since the light is again going from denser to the rare medium. So it not happen with all the light which is coming towards the droplet. But few of the light rays which is coming towards the droplet can have a angle more than the critical angle. So when the angle of incidence is more than the critical angle, what happened? In this light drop, in this water drop, the light is totally internally refracted. Now like this. The total internal reflection of light takes place and passes from the raindrop to the air. So in this case, in this raindrop, the light color, the total internal reflection of the light takes place. Now when the light is again coming from water into the air, what will happen? It will again bend away from the normal. Okay. So it will bend away from the normal like this. And we get the wave. We get the seven color by this raindrop. So this is the wave. And if we are here, so we are able to see the seven colors. And since lots of raindrops are present in the atmosphere, so most of raindrops are present in the atmosphere. So these raindrops, all the raindrops act like a prism. And with the combination of these seven colors, we can see the rainbow formation, the rainbow formed by these droplets. So this is all about the rainbow formation. So again, if we explain the rainbow formation, first you should write what should be the important condition which should be there for the rainbow formation, that is the sunlight and the rain. And second thing, you will explain all these things. This one is not, you have to explain, it is only for you. You should understand how the total reflection of light takes place in the raindrop. So this, you don't write this one, but you have to write it with your explanation, like when the light is passing from the air into the water, it's split into seven color. Then when the light is passing from the body to the air, the total internal reflection of light takes place. And again after total internal reflection, the light comes from water into the air, the refraction of the light takes place. and that's why we are able to see the rainbow. So this is the rainbow formation. Now I will explain you atmospheric refraction. First we should know what is atmospheric refraction and what is the meaning of this. Since the name suggests the refraction due to the atmosphere is called the atmospheric refraction. The reflection of the light takes place through the atmosphere. What is possible? You know that in atmosphere we have the air. Atmosphere is made up of air, and this air can have the different optical densities in different levels. Suppose this is Earth, and in the lower level, density of the air is higher as compared to the upper levels. Since the density, since the we can say the amount of gases present near the atmosphere and near the Earth is more as compared to the upper levels. So we can say the layers which are present towards the Earth, what we can see which is near to the Earth, is denser as compared to the upper part. So this different optical densities, it's again it can be happen that if a warm air is present in the atmosphere, it should have a rare. It will behave like a rare medium, and the cold air will behave like a denser medium. And the atmosphere of the different altitudes do not have the same atmosphere. This atmosphere can be changed. So we can say that the density of the atmosphere can be changed. It depends on the blowing of warm air or the cold air. So first we should know that Earth atmosphere having the different optical densities. For example, the air which is present near to the Earth is behave like optical density medium, and the air which is present above the Earth is at the high altitude from the Earth's surface having the rare medium. It behave like a rare medium. So what will happen when the light passes from this rare to the dense medium? Suppose this is the Earth, and I am representing the air layers by these things. Actually, these are not particularly. There is no any boundary between these layers. This is happened like upper layer is rare, and when we come towards the Earth, the air become dense. So for convenience, I am representing it by the different mark like the layers. These are not actually the boundaries. What will happen when the light passes from it? Since it is passed from the rare to dense medium, it will bend towards normal again. So it means the bending of the light takes place through the atmosphere, and this refraction of the light which is caused by the atmosphere is called the atmospheric refraction. So you can also write the definition of the atmospheric refraction. The reflection of the light takes place through the atmosphere due to the different optical densities of atmospheric layer is called the atmospheric refraction. Okay, so this is the atmospheric refraction. Now, in our NCERT book, we have one question that is when you see from a fire, suppose there is a fire, there is a fire, and suppose you are here and you are looking through the fire, or you can see from above the air present above the fire. Suppose there is an object. This is an object, and you want to see the subject. You have noticed that this object appeared to flicker. How it's possible? It's possible because this fire, we know that it is a very high temperature. So the air present above the fire is also having the high temperature. And is in compared with the surrounding surface. Means the air surrounding the fire having the low temperature as compared to the air above the fire. Due to this fire, the air which is present above the fire having the high temperature as compared to the other atmosphere, other surrounding air. Since, one more thing you should know that higher temperature means the temperature of the air is higher, means this is behaving like a rare medium. Or if the temperature of the air is less as compared to other one, it behaves like a colder medium. It behaves like a denser medium. Again I am telling you, that suppose a same amount of air is present, but the air which having the high temperature will behave like a rare medium, and the air having the lower temperature will behave like a denser medium. So here in this case, since the air which is present above the fire having the high temperature as compared to the air which is surrounded as compared to the surrounding air, so it means this behave like a rare medium, and the surrounding air will behave like a denser. So how are we able to see the objects? We can able to see the objects when the light is passing from this. When the light is coming from the object and falls on our eyes, then we are able to see any object. So when the light from the object passes from these different layers, like the denser and the rare and the denser medium, and the densities of this medium can be varied. So due to this atmospheric refraction, this is also called atmospheric refraction caused by the atmosphere. We can't see the atmosphere with the air. So this refraction of the light, due to this refraction of the light, the object appear to be flicker. So this is one question. First you have to write the definition of atmospheric refraction. I explained you that the refraction of the light which is caused by the atmosphere due to different optical densities of atmosphere is called atmospheric refraction. Again, the first question is give reason why object appear to be flicker when we saw these objects with the fire. Okay, why the object appear to be flicker when we saw these objects with the fire. So you can write the answer like this. We know that the air present above the fire having the high temperature as compared to the surrounding air, and the temperature, if the temperature of the air is higher, it behave like a rare medium, and the air which has low temperatures behave like a denser medium. Since the air which is present above the fire having the high temperatures, it behave like a rare medium, and the surrounding air behave like a denser medium. And due to this different optical densities, when the light comes from the object passes from these optical different optical densities, it appear to be flicker. So first question is you will write answer yourself why the object appear to be flicker when we saw the object from fire. Okay. The second one is, this is the first one that give reason. Second is, what is the reason behind a twinkling of a star? So I will explain the twinkling of a star. What is the meaning of twinkling a star? Twinkling a star means you can see any object. If the light coming from the object falls on our eyes, then we are able to see that object. Then how we are able to see the stars? The light from the stars falls on our eyes, and due to which we are able to see the stars. Then what happened actually in case of twinkling? When the stars twinkle, actually sometimes the light falls on our eyes, and some other times it do not fall on our eyes. And this is also can we see that sometimes the stars look bright and sometimes it look dim. So this bright and dim is called the twinkling of stars. So when the stars bright, it can be seen easily, or when it is dim, so it's like we are not able to see the stars. So this is called the twinkling of stars. So the bright and the dim, and the bright and the dim is called the twinkling. So let's understand how the twinkling of stars takes place. You are here in the atmosphere. The stars, the light coming from the stars have to pass from the universe, that is called the vacuum. So since the universe has the vacuum, so the refraction light do not take place. But what happens when the light falls on the atmosphere? When it passes from the Earth atmosphere. So you will explain it like this. We know that the Earth atmosphere having the different optical densities. The air which having the high temperature will behave like a rare medium, and the air which having the having the low temperature we bring it like a density. So the atmospheric air have the different optical densities. So what happens in case of twinkling? When the light is passes from these optical densities and falls on our eyes. So when the light passes from the different optical densities and falls on our eyes, then we are able to see the stars clearly. Since the atmospheric densities continuously changes, these atmospheric densities continuously changes due to the reason that there can be the flow of warm air. So in between there should be a there can be possible that different density air can be present here, like कहीं पे गर्म हवा चल रही है और वो अचानक से गर्म हवा आ गई तो क्या होगा कि वहाँ पे रेयर मीडियम बन गया. So when the light comes from the stars falls on our eyes, we are able to see the stars. Since the stars are very far away from us, so it can be represented like a dot. So from this dot, when the light comes from atmosphere and falls on our eyes, we are able to see the stars. But this atmosphere having the different optical densities and it is always changes. These optical densities are varying, are changes continuously. So due to which what happens, sometimes this light do not falls on our eyes. So sometimes it falls on our eyes and it can be possible that the optical density of the air changes. So what will happen? This light will not fall on your eyes. So when it falls on our eyes, we can see the bright light. And when it do not falls on our eye, we are not able to see the stars. So we can say like bright and dim and bright and dim. This is called a twinkling of stars. So inside second revision, you will write the answer of this question: why the twinkling of stars takes place. So you can write the answer for the twinkling of stars, that the continuously changing atmosphere refract the light with the reflected bound from one moment to the next. So when the refraction, due to the reflection of the light, when the light falls on our eyes, it appears to be bright, and due to the less reflection towards it, it appears to be dim. And this bright and dim light is called the twinkling of stars. So okay, the more question is, it can be here. Then why the stars twinkle and the planet do not? We have seen the sky, night sky, that the Venus planet, so it appears very bright in the sky, night sky. So why the planet do not twinkle whereas the stars twinkle? So you can explain its answer like this. The stars are very far away from us. So we can imagine that this is a point source of light which is coming from the large distance. So this is like a point source of light. And the planets, since the distance of the planets is less as compared to the stars, so it appears to be large. It's not large in size, but it appears to be large because the distance of the planet from the Earth is less. So we can understand it like this. This is the point source of light. So in case of stars, sometimes the light after refraction falls on our eyes and sometimes not. And due to which we can say that the stars twinkle. And what is called the planet? This is large in size, so we can imagine it like the collection of the point source of light. If this star is a point source of light, then this planet we can imagine it like a collection of point source of light. So if some part of this point source, the light of this part of point sources do not reaches our eyes, then it means it appears to be dim. But it nullified by these point of sources which we can see. It means आप इसको ऐसे समझ सकते हैं कि सपोज यहाँ से जो लाइट थी तो आपके हाथ पे नहीं आ रही थी, तो आपको ये पार्ट दिखाई नहीं देगी, लेकिन इस पार्ट से लाइट अभी भी आपकी आँख में आ गई, तो जिसकी वजह से क्या हुआ कि इसका जो दिल था उसको इसने नलीफाई we discuss size because the stars having the large size. So it not behave like a point source of light, it behave like a collection of point source of light. So if the light from the some point sources do not falls on our eye, it can be nullified by the light which reaches our eye from the other parts of the planet. So this is the third key reason why stars twinkle but planet do not. Now the next is, yes, the stars actually appear higher than their actual height. So we can understand it. The question is, the reason is why stars appear to be higher than they actually are. So what happened? We can understand it by using the figure. So when you will write this answer, you have to make a figure along with the answer. This is the star and suppose this is the earth. And you are here for seeing this star. What will happen when the light passes from the atmosphere? Now you will write the answer like this. The atmosphere which is near to the earth's surface is denser as compared to the upper air. So the light coming from the stars reflect when it entered into the atmosphere, since it passes from the rare to the denser medium. This is the rare medium, this is the denser medium. So I am representing it by making the figure like this. Actually the earth do not have any type of layer like this, but there is not a certain boundary here. Actually this is the rare air and this is the denser air. As we move towards the earth, density of the air is increases. So what happened when the light entered into the atmosphere, into the earth atmosphere? It bent towards the north. Since the light is coming from the sun, from the stars, entered into the atmosphere, now it entered into the rare to the denser medium. And we know that when the light passed from the rare to the denser medium, it went towards the north. So it bent like this. Again, when it passes from the atmosphere, this type of refraction of the light takes place. Since it passes from rare to denser medium. And over here, we are here to see this star, and if we make a figure of the stars, it appeared at this height, but the actual height of the star is this one. So the stars appear to be higher than the actual height because of the atmospheric refraction. Here we will explain what type of atmosphere is present near the earth and what type of atmosphere is present far from the earth. It means the atmosphere having the different optical densities. As we move towards the earth, density of the air is increases. And we know that when the light passes from the rare to the denser medium, it bends towards the north. So in case of the star, when the light passes from the different atmospheric layer, it bends towards the normal. And you do this by making this figure like this, you can explain that, and you do this that stars appear to be higher than their actual height. So this is the next key reason. Okay, one more. Advanced sunrise and delay sunset. Yes, advanced sunrise and delay sunset. You know, this is Earth, suppose. And we know that around the sun, our Earth revolving like this, and it's also rotating on its own axis. So suppose this is sun, and you are here. So you are not able to see the sun. It means no sunrise. And when this Earth is rotating, you will move here. Now you are here. You are able to see the sun. So you will see sunrise. So it means you are able to see the sun when the sun is near the horizon. Horizon is cool. So near the horizon. So we can explain it like this. This is the sun. And we can understand we are able to see the sun when this is on this horizontal line. But in actual cases, it's not happened. We are able to see this star, this sun, before the sunrise. It means it's not at horizon, but we are able to see it. How it's possible? So we can see sun before 2 minutes before the sunrise, and after sunset we 2 minutes after the sunset. So how is possible? Again there is one thing, that is the air which is near to the earth's surface is denser as compared to the air which is present in the upper part of the atmosphere. So when the light is coming from the sun, it enters the atmosphere. The refraction of the light takes place, obviously, because there is a different density of the air in different altitude at different height. So when it enters the atmosphere, what will happen? When it enters the atmospheric layer, it refracts into the atmosphere. So it refracts. So this is normal. You know that when the light passes from a denser to rare to denser, meaning it bend towards the normal. So it bent like this. We are here to see the sun. So if we make the figure of the sun, it will appear that it is here. Though the actual position of the sun is here. So I think I should make another figure. So when you explain this answer, you should make a figure with your answer. So this is Earth and this is here you are to see the sun. This is the horizontal line and sun is here. Now you can make figure like this for explanation. Actually these are not actual here, these are not the actual boundary. So when the sunlight enters into the atmosphere, it bends because it entered from rare to the denser medium like this. Now the sun will be appearing here. It means we are able to see the sun before 2 minutes before the sunrise and after 2 minutes, 2 minutes after the sunset. So it means our sun is 4 minutes longer than actual length. So these are few questions related to the atmospheric refraction. This was question number 5. Reason behind the reason for the advanced sunrise and previous sunset. So this is all about the atmospheric refraction, different applications of atmospheric refraction, and these are the different questions of give reason. So, okay. Now we will continue this chapter in next video with the sketching of the light. How the sketching of the light takes place, how the different color of light is scattered with a different amount. So we will discuss it in next class. Okay. Till then, bye.